Hello everybody. So today we are going to discuss about the next part of the machine chapter. Last class I have discussed about the mechanical advantage of a simple machine, the efficiency of the machine, etc., and the functions of a machine. So today we are going to discuss the next part of that chapter, that is the principle of lever. So lever is a kind of machine. It is actually a rod. Either it may be a straight rod or it may be a bent rod, and it has a particular point where on the position of the point, that particular lever actually works. That particular fixed point of the lever is termed as the fulcrum. So here there are the 3 points to be remembered. One is the effort, second is the load, and third one is the fulcrum. So actually the category of the lever, it depends on the position of the fulcrum. So first let us discuss about the class 1 lever. Now in the class 1 lever, this is the diagrammatic representation of a class 1 lever. So class 1 lever, at the point A we are applying the effort. Let me discuss about first the principle of the lever, then we will discuss about the class 1, class 2, class 3 lever. So it's a lever. Now let us consider this is the point A, this is the point where the effort is applied, point B where the load is applied, and point C, the triangle, it shows the fulcrum, that means the pivot point of a lever. Now the principle of lever, it states that load into load arm is equal to effort into effort arm. Now if you consider the load is equal to L, so what is the load arm? Load arm means BC. The distance between the load and the fulcrum is termed as the load arm. So load into load arm, L into BC, is equal to effort into effort arm, so E into AC. Now load by effort, that is AC by BC. That means load by effort means effort arm by load arm. In the last class I had a discussion. I discussed about that particular point, that load by effort, that is actually termed as the mechanical advantage of a machine. Ratio in between the load with the effort, that is termed as the mechanical advantage. Now L by E means the mechanical advantage. So in other term you may say that the mechanical advantage of a lever, it is nothing but the ratio of the effort arm with the ratio of the load arm. Now it is obvious that if the effort arm, by any means, if the effort arm is more than the load arm, then AC is greater than BC. So the mechanical advantage is greater than 1. Then the machine will act as a force multiplier. If I discussed about that force multiplier and the speed multiplier in the last class. And if the effort arm is less than the load arm, then the mechanical advantage is less than 1. And if the effort arm is equal to the load arm, then the mechanical advantage is equal to 1. So in a principle of lever, it states that load into load arm equal to effort into effort arm, and load by effort or mechanical advantage, it is the ratio of the effort arm with the load arm. Now come to the class 1 lever. In class 1 lever, the fulcrum is situated in between effort and the load. It doesn't mean that the fulcrum is situated just at the middle part. It may be closer to the load, it may be closer to the effort, but but that should be in between the effort and the load. That is the class 1 lever. This is the diagrammatic representation. Now you see in this diagram, AC is greater than BC. So the mechanical advantage is greater than 1 according to this drawing. Now if you consider that I am placing that effort just at the middle, consider the effort is the fulcrum is situated just at the middle. So AC and BC both are same, then the mechanical advantage is equal to 1. Now consider if I place that fulcrum near the load, near the effort. then the load arm is greater than the effort arm, that means the effort arm is shorter than the load arm, then the mechanical advantage is less than 1. So in a class 1 lever, it depends on the position of the lever. It is situated in between effort and load. But if it is situated just at the middle, the mechanical advantage is 1. I am giving you one example. You know about that, the spring balance, the beam balance. In the grocery shop, you know that this kind of beam balance they are using to measure the weight of the object. Actually, they are using this beam balance to compare the masses of the two different objects. So here this is a kind of, that beam balance is a kind of class 1 lever where the fulcrum is situated just at the middle, where the mechanical advantage is equal to 1. Now if you consider that scissor, pair of scissor, this is also an example of class 1 lever. Here this is the position of the fulcrum, and here I am applying the effort, and here the paper or the piece of paper or the cloth is there. So you see it is very clear that the effort arm that is actually in the pair of scissor, it is, you see that the effort arm, it is shorter. It's obvious the effort arm is shorter than the load arm. So here the mechanical advantage is less than 1. But here, that example of a scissor, it is an example of class 1 lever where the mechanical advantage is less than 1. But if you think about that, the say what kind of example it is given in your book, let me see, that the pair of pliers, you see that the pair of pliers, here you see that the effort arm, here it is the position of the fulcrum, and you see that the effort arm is more than the load arm, and here the mechanical advantage is more than 1. So these are some examples, that seesaw, pair of pliers, pair of scissors, the beam balance, the crowbar, the claw hammer. You see the claw hammer, you are applying the effort, and here it is the fulcrum just at the middle, and that position of the nail, that is the load. So here it is the example of class 1 lever. In class 2 lever, the load is situated in between effort and the fulcrum, and here always you see that diagram represent that the load arm is always shorter than the effort arm, or in other words, the effort arm is longer than the load arm. So the mechanical advantage of class 2 lever is always greater than 1. Now you see, these are the examples. You see the nutcracker, you see that this is the position of the fulcrum, the load, that the nut, it is situated in between that effort, this is the effort point. Wheelbarrow, you see this is the position of the fulcrum, this is the load, and here it is the effort. You see that the bottle opener or the lemon squeezer, you see that bottle opener or the lemon squeezer, you see this is the position of the fulcrum, this is the effort, and here it is the load. So load is situated in between fulcrum and the effort, and here the mechanical advantage is always greater than 1. Now come to the class 3 lever. This is the diagrammatic representation of the class 3 lever, and you see the fulcrum is the effort is situated in between fulcrum and the load, and obviously that the effort arm, that is AC, is always shorter than the load arm BC. So the mechanical advantage of class 3 lever is always less than 1. And you see the examples of that class 3 lever, a pair of tongs. In the pair of tongs, you need this. You see that here it is that the effort we are applying, that bending position, here the fulcrum is situated, and here it is the load. You see that the knife also, you see that knife, we are applying the effort, and here it is the here it is the effort point, and here it is the fulcrum, and here it is the load. Sugar tongue, you see this is the position of the fulcrum, and here it is the load, and the effort is situated in between fulcrum and the load. So these are the examples of class 3 lever. So you please practice all the kinds of these three, drawing of the three kinds of the lever. I'm talking about the diagrammatic drawing of class 1, class 2 and class 3 lever. And you see, mind that, you see that in the class 1 lever, the direction of effort and direction of load both are in the same direction. But you see in the class 2 and class 3 lever, the direction of load and effort, these are different. Direction, I'm just giving you just an idea of that, it is a different direction. You see that to cut anything, this is the class 3 lever. So you are applying the effort. So it is the downward direction, and the load, that is in the upward direction. I am giving you another common example. Say I am holding anything on my palm. Okay, so this particular elbow, here it is acts as a fulcrum. Okay, here it is acts as a fulcrum. Now we are applying the effort. So we are applying the effort. So effort, you see, it is in the upward direction, and the weight of the object, that is the load, in the downward direction. So always care about the direction of the effort and the load in the three kinds of the lever. So up to this much today. Thank you.